So you can see it exactly is coming between the two curves, and it is going to peak at the center frequency, which is usually called as F0, and the other side frequencies are F1 and F2. So F1 is going to be the frequency, resonant frequency of tuned circuit 1. F2 is going to be the resonant frequency of tuned circuit 2. So in this case, I can make my circuit to have extra bandwidth also. So they have seen that by doing this, the bandwidth is going to be root 2 times it is going to increase from the single tuned amplifier. If single tuned amplifier is going to have a bandwidth of capital B, then the stagger-tuned amplifier is going to have a bandwidth of root 2 into B. You know, root 2 value is 1.414. So it is multiplied by 1.414. So effectively my bandwidth is going to increase by a fraction root 2. Okay. So when your bandwidth is going to increase, your quality factor will reduce. Okay, quality factor will reduce. So that is going to have a very minimal impact on the selectivity of your circuit. But what they are saying is, even though I'm going to connect this circuit in a stagger tuned form, the selectivity is also going to be same as single tuned, double tuned system only. It is also not going to change. So effectively, I am connecting two circuits in cascade, having two resonant frequencies F1 and F2 in such a way that they are displaced from F0 by an equal amount. That equal amount is going to be your bandwidth. They have marked B on both sides. If you see, that is going to be the bandwidth of the single tuned amplifier, single stage. Okay, so this is the concept of stagger tuned amplifier. We don't have derivation as such in stagger tuned amplifier. We are just going to have the concept because it is going to be single tuned only, right? So for single tune, we know the diagram and derivation, other things we have done in detail. So we will not be deriving the complete mathematical derivation for stagger tuned amplifiers, but we will just be deriving what is the effect of cascading stagger tuned amplifier. So the gain for a single stage tuned amplifier, you know, we have derived this. This is the single gain of a single tuned amplifier. A by A resonant equal to 1 by 1 plus J 2 delta Q. I hope you remember this equation. This equation only we use for calculating the bandwidth. This equation only we use for calculating the effect of cascading single tuned amplifiers on bandwidth. So this equation should be very familiar too. For simplicity, I am taking this X as 2 delta into QE. So my A by A resonant ratio becomes 1 by 1 plus JX. Okay, this is for a single tuned amplifier. Since stagger tuned amplifier is going to be cascading of single tuned amplifier, I am going to use this equation to multiply the gain of the two stages. And you know the equation, bandwidth equal to F0 by QE. Or the delta is the frequency shift. Delta is 1 by 2 QE. So or I can write the bandwidth in terms of delta as bandwidth equal to 2 delta into QE. So QE is going to be 1 by 2 delta. So if you substitute in this formula, B is equal to F0 by 1 by 2 delta, or B is equal to 2 delta into F0. So if one stage is tuned to the frequency delta F0 below F0, the other stage is tuned to the frequency delta F0 above F0. So delta F0 below F0 means delta F0 minus F0. So I can take delta outside. I get delta into, I can take F0 outside. So it is going to be F0 into delta minus 1. So if the other stage is going to be tuned to the frequency above F0, so it is going to be delta F0 plus F0. If we take F0 outside, it is going to be delta plus 1. So I can, in this way, the frequency of the tuned circuit are shifted on either sides. Okay.